Hello students, in the last class we discussed about the sulfur dioxide preparation and its properties. In this class we discuss about the next compound, sulphuric acid. This sulphuric acid is called as an king of the chemical, also called as an oil of vitriol. Oil of vitriol and king of the chemical. Then manufacture of sulphuric acid by using contact process. Manufacture of sulphuric acid by contact process. First step that involves different steps. First step is the formation of sulfur dioxide. How that sulfur dioxide formed means by burning sulfur in air. By burning sulfur in air forms SO2, or by roasting iron pyrite FeS2 plus O2, that gives SO2 plus Fe2O3. By burning sulfur or by roasting iron pyrite, that is 4 FeS2 and 11 O2, 8 SO2 and 2 Fe2O3. This is the first step, formation of the sulfur dioxide. Then second step is purification. Purification of the gases. Why we have to purify the gases means if any impurity is present, they poison the catalyst. Impurity is present in the gases, they poison the catalyst. Hence, you have to purify the gases before passing through the catalyst chamber. That can be purified by passing through the different chambers. Among them, one is dust chamber. Then the gases, after by passing through the dust chamber, they can be dried. By using concentrated H2SO4. Then dried gases passed through the arsenic purifier, which contains ferric hydroxide. That arsenic purifier contains ferric hydroxide, which absorbs the arsenic impurity. Arsenic impurity is the main catalytic poison. It is the main catalytic poison which can be removed by the ferric hydroxide. It is very important for that competitive. Arsenic purifier consisting of ferric hydroxide, which removes the arsenic impurity, which is the main catalytic poison. This is about the purification of the gases. Then after purifying the gases, next step is oxidation of sulfur dioxide. That purified gases then passed through the catalyst chamber, preheated catalyst chamber in the presence of the vanadium pentoxide catalyst, where SO2 oxidized to SO3. 2SO2 plus 2SO3. SO2 by using vanadium pentoxide catalyst and at a temperature of 720 Kelvin and 2 bar pressure. This is important one. Conditions are important. And the enthalpy of this reaction is minus 196 kilojoule per mole. That is oxidation of sulfur dioxide means that purified gases then passed through preheated catalyst chamber packed with vanadium pentoxide, where SO2 is oxidized to SO3. Sulfur dioxide is oxidized to sulfur trioxide. Favorable conditions according to Le-Chatelier's principle are vanadium pentoxide catalyst and at a temperature of low temperature of 720 Kelvin, high pressure of 2 bar. Why we are using the low temperature means because it is an exothermic, and high pressure means because 2SO2 gas, O2 gas, 2SO3 gas, 3 moles converted into 2 moles, 3 gaseous moles converted to 2 gaseous moles means you have to maintain a high pressure. Then next step is adsorption of SO3. Adsorption of SO3. That formed SO3 passed through 98% of H2SO4. that is absorbed, not absorption, absorption of that SO3 is absorbed by 88% of H2SO4 to form H2S2O7. It is commonly called oleum. Oleum means mixture of that SO3 and 98% H2SO4. Formula is H2S2O7 or fuming sulfuric acid. This SO3 not absorbed by water. Why it not absorbed by water means because SO3 when reacts with water, it forms the dense white fumes which are insoluble in water. Hence SO3 not absorbed by water. To absorb SO3 only we are using 98% H2SO4. Last step is dilution. This oleum H2S2O7 is diluted with calculated amount of water. We get the concentrated H2SO4. It is diluted with water to get the concentrated H2SO4. This is about the manufacture of sulfuric acid by contact process. This is important one. In 2020 annual exam, they asked that preparation from that purified gases, that is oxidation of SO2 to dilution. That carries the 3 marks. Each step carries 1 mark. 2SO2 plus O2 conditions. 2SO3. SO3 98% H2SO4 forms H2S2O7. H2S2O7 are treated with water forms H2SO4. Then finally you write the flow chart. The flow chart for that contact process is, first one is pyrite burner. From the pyrite burner we get the SO2. SO2 can be purified by using dust chamber or with dryer. Dryer contains concentrated H2SO4, or with the arsenic purifier, ferric hydroxide. Then Tyndall box. The Tyndall box role is to check the purity of the gases by using a beam of light. If it is impure, again recycled, that is again purified. If it is pure, then passed pure sulfur dioxide, then passed into the catalyst chamber. Catalyst chamber contains V2O5 at 720 Kelvin and 2 bar. The gas coming out of the catalyst chamber is SO3. Then SO3 passed into the absorption chamber, contains 98% H2SO4. The gas coming out is H2S2O7, that is oleum. Oleum is diluted with water. You get the concentrated H2SO4. This is the flow chart. The next class we study about the properties.